Hello, friends. I'm Commander Rohati speaking to you on behalf of ISRA Institute of Excellence once again. Continuing with our series of talks, II Delhi HVAC talks, we are going to start a new series of talks, and this series is about duct design. A lot of our students had requested me to start a series on duct design, and that is what we are starting today. And to start with, we will talk about the need of duct. Why do we need a duct? The ducts are required to take air from one place to another. We need to take air either from the air handling unit to the compartments, or sometimes from the compartment we need a duct to take air from the compartments back to the AHU. Sometimes we need the duct to take the air from the compartment to outside or wherever. The air does not travel on its own through the duct. Fans are needed to drive the air through the ducts. Fans can push the air through the ducts. Fans can also pull the air through the ducts. So the ducts can be used for supply as well as for exhaust. And ducts, they need to be carefully designed for fulfilling the objective of moving required quantity of air. We cannot have any size of duct or duct of any configuration. The duct design has to cater for the objectives that we have at the time of designing. The considerations that we make for duct design is the first and foremost is available space. Do we have the space available to lay the ducts? Because the ducts cannot be laid in where space is not available. Where the space is occupied by something else, we cannot lay a duct. The space has to be available. Second thing is that what is the level of sound or noise that is permitted? How much sound or noise will be produced when the air will be traveling through the duct? And the duct design has to take that into account. Possibility of condensation depends on the what is the temperature of air that is inside. Is that below dew point or is it above dew point? In case if the temperature of the air is below dew point as compared to that of the air that is outside, then while designing the duct, we also have to think about insulation. Otherwise, condensation will take place, which will be undesirable. We have to think about pressure level that we are going to maintain. In fact, the pressure level at which the air is going to be driven through the ducts, because the duct thickness, the duct stiffening will depend on that. The air velocity, what is the velocity of air? See, the amount of friction that takes place inside the duct, that depends on the velocity of air. The higher the velocity, the more will be the frictional losses. So a duct which is bigger in cross section will offer less. Bigger in cross section will mean that the velocity is less and will offer less frictional losses, whereas a duct which is smaller in cross section and is catering for higher air velocity will offer much more frictional losses. Frictional losses, the air leakage, the leakage of air that is allowed or that can take place, and then the thermal stresses. Sometimes the ducts are also used for removal of hot gases, hot smoke, and in such cases the duct material will experience a lot of thermal stresses, and unless it has been made with the required kind of material which can take care of that, which can withstand those thermal stresses, the duct system will fail. So while designing the duct, we have to take all these factors into account. Now let's compare the round ducts versus rectangular ducts. The material required for making a round duct is least, whereas the material required for a rectangular duct is higher. The noise that is produced when the air is traveling through a round duct, that also is least. That is the round ducts, they offer most smooth flow of air. Frictional forces are also the least as compared to rectangular duct. But here the question comes that in case if all these good points are there in round duct, why do we use rectangular duct at all? Because we have a limitation with round ducts. We cannot accommodate round ducts because their diameter will become very large, and we will not be able to utilize the space that is available properly, and also that much height may not be available in many times, or rather the ducts have to be laid on floors, in between floors, and the floor to floor spacing is limited, and in that we have to take into account the head space required for movement of men. Then we have to account for the beams, we have to account for false ceiling, we have to account for other systems like fireman system or water system or electrical cabling system. So the height that is available between floor to floor, that has to be properly utilized, and when the quantity of air is large, round ducts are not suitable because they will become, the diameter will become too large to accommodate. Now when we have rectangular ducts or square ducts, in square ducts, this A and B, that is height and width, will be the same. But once again, in square ducts will not suit all requirements. Many times, when because the height that is available, that is limited, we have to have rectangular ducts so that we can utilize the available space more efficiently. However, when we have rectangular ducts, there is a limitation that this aspect ratio, that is what we are seeing is the cross section of a duct, the height of a duct and the width of a duct. This aspect ratio, that is A to B, that should be always between one is to 1 to 4 is to 1. If I compare the circumference, we are trying to compare the cross section of 400 centimeters square, and if we calculate for 400 centimeters square, the duct dimension will be, the circumference of the duct will be 71 centimeters. On the other hand, we could have certain possibilities for having a rectangular duct. Let's say that we have listed some of the possibilities, where the dimension A is 5, 10, 15, 20, 25, 30, and based on that, for having the cross sectional area of 400 square centimeters, B is 80, 40, 27, like that. And obviously, so all of them is not possible, is not recommended, because the first one, like the first one that we see, the first one is not passing the test of the aspect ratio of which has to be between 1 is to 1 to 4 is to 1. It is 16, so obviously it is not suitable. But when we have the second, the third, the fourth, these are within our possible cross sections. But when we see that, what is the perimeter, because perimeter will indicate what is how much material will be required for making the duct. We see that uh, when the ratio is 1 is to 1, the perimeter is the smallest, that is 80. And the moment the ratio increases or decreases, the perimeter starts changing, and the perimeter starts changing, and perimeter, when the perimeter is higher, that means we are going to consume more material. So more material will mean more cost of making material, more material cost, more weight of the duct, and also more frictional losses, and such problems are there. Now, talking about what is the material with which we can make a duct. Ducts are normally made with GIC, that is galvanized iron sheet or galvanized steel sheet. Uh, in certain special purposes, special purposes, the ducts could also be made with stainless steel. Ducts could be made with aluminum sheets. Duct could, and these are, when I'm talking about sheets, we are talking about sheet metal joints, thin sheets with sheet metal joints. But whenever the pressure becomes high, the pressure requirements become high, we have to go in for welded stainless steel or welded mild steel ducts also. The ducts can also be made up of cloth, and then the ducts can also be made with flexible. They could be made with flexible rubber. Particularly near the diffusers in the compartment, the ducts are made up of flexible rubber. This helps in connecting it to the diffuser. That is one. And second thing is use of flexible rubber also helps in solving acoustic problems. Thank you for watching me. You can keep coming to State Institute of Excellence YouTube channel for clearing your doubts, for upgrading your skills, for upgrading your knowledge. You could also write to us for in case if you need any special video, any comment on any HVAC related issue. We will love to talk on it. Thank you very much. We at Israel Institute of Excellence, we offer a number of courses for upgrading the skills of professionals. The fresh engineering students, they could also join us in case if they are willing to join the HVAC and refrigeration world, which offers exciting careers. We offer many courses, which are some of them are online and some of them are offline, that is face to face. You could contact us for more details. We are present on YouTube, we are present on LinkedIn, and we are present on Facebook. We have a website, and you could contact us on these telephone numbers which have been given here. Thank you very much.